Hi, welcome to another class on art programming as a part of Introduction to Data Science subject. We are in the fourth unit and we are talking about the fundamentals of art programming. So, previously in R, we talked about vectors, which are single dimensional placeholders or data structures, only one dimensional and same homogeneous atomic data type elements. And then we talked about matrix. Then we talked about matrix or two-dimensional, arrays or three or more dimensional. Then we talked about factors. Then we talked about data frames, and we talked about finally we discussed about lists. So factors and lists they can hold heterogeneous data elements, and but the factors the condition is that every column should have same number of rows, but in lists we don't have that restriction, so lists are more flexible compared to this one. Now we are going to see the next topic, that is the operators, and though there are many operators we'll be restricting ourselves to relational operators and logical operators as per our syllabi. So this is what we are going to see in this class. So relational operators, they are also called uh, comparison operators. So relational operators are used to compare different operands. So the operators are equality symbol. Then we have not equal to. Then we have less than, greater than, less than or equal to, greater than or equal to. So these are relational operators. So let us do some programming about this. So firstly, the operator equal to or equality, it checks the equivalence. So this operator, equality operator, checks the equality and it outputs Boolean variable. In fact, as a matter of fact, all the logical relational operators they output Boolean variable, whether that is either true or false. So this is what we are going to see, right? We can check equivalence between anything. Uh, Let us say I have two numbers, 2 and 3. I'll check the equality. So obviously, what will be the answer? 2 is not equal to 3, right? So it will be false. So then, and when you compare, similarly, 2 is not equal to 3 will result in true. This is comparing the numbers. We can also compare the characters, right? So A, whether it is equal to, it is not equal to capital A. And ABC, is it equal to, again, ABC? This is true. So that is the equality operator and not equal to operator. So we can use even Boolean variables. True, it is equal to true. So the answer will be true. False, equal to false. That will be true. So true is not equal to false. That will be true. True equal to false. That will be false. So equality symbol is used to check the equivalence between different types of categories of variables. And we can also use comparison between. So whether it is greater than or less than, suppose you have number 3 greater than 5, it will be false, whereas 3 less than 5 will be true. Then we have uh, 2 less than or equal to 2, 3. That will be true because 2 is less than or equal. Then 3 is greater than or equal to 2. That will be true. So what we have seen, equality symbol, then not equal to symbol, then we have seen greater than or equal to, less than or equal to. All these operators we have seen. These are relational operators. Now, till now, what we have done is we have seen the uh, individual independent elements we have seen, but in our programming, we'll be working with vectors. Even character strings are something like vector of the character, right? So, for example, I say hello. It is greater than hello. So, what it will do is it will compare these two letters, first two letters, because H comes before after F. H is considered as greater. So, this will return as true. Similarly, we can define some vectors. Let us say A is a vector, say of some marks, let us say 1, 2, 3, 4, 5. Then 6. Then B is another vector. Let us say 1, 2, 3, 7, 8, 9. Now we can perform the comparison element by element using the relational operators. For example, I check now A equal to B. So what it will do, this will perform something like a for loop. It will it will compare that operation for all the elements. 1 1 equal, that is true. 2 2 equal, that is true. So it will compare element by element, and when all are equal, it will give true, and from here they are not equal, so it will give false. Similarly, I can write A greater than B. So it will compare each elements of A and B, and whenever it is greater, it will give true, otherwise it will give false. So this will be false, this will be false, this will be false, this will be false, and all things will be false because A elements are not greater than B. Similarly, if I say A less than B, so this is false, this is false, this is false, this is true, and this is true, and this is true. So this is how we can work with vectors using the relational operators. Now let us see the uh, logical operators. Logical operators. So what are the logical operators which will check the true and or operators? So we are going to see and or not. These are logical operators. So we know the truth table, right? And is indicated by ampersand symbol. It is indicated by ampersand symbol, and or is indicated by a bar, vertical bar above the enter button. You know these things very well in C, so that's why I'm just brushing up the fundamentals. So you know the truth table, true and true is true, true and false is false, and false is false. So let us take two statements. Let us say A is equal to 2 and B is equal to 3. So A less than B. Oh, it is minus 3. So A is greater than B. A is false statement and B is greater than A. That is true statement. So let us say true and true. Now let us apply A greater than B and A greater than B is false and B greater than A is true. So obviously this will be false. So true and true will be true and all the remaining things false and true, true and false and false, all those things will be false. Then logical OR is used with uh, false or true is true, true or false is true, then true and true is true. So now let us write the same thing, what we have written here. A greater than B is false and B greater than A is true. But what I'm doing is stop and I'm applying OR and it will be true because for OR gate, even if one of the input is true, it will produce the true. And negation is also there. So negation of true is false and negation of false is true. So not A greater than B. A greater than B is false. Negation of false is true. Negation of A less than B. A less than B is true and true negation is false. So that's the negation. Let us see how we can apply these things for
vectors. Now let us define a vector A with Boolean variables. False and another vector B false, false. Now if I perform A and B, what will we have? What will happen? You know that vectors, each element will be operation will be performed on each element. So true and true will be true, true and false, false, false and false, false, false and true, false. So you can see that the first one is true and the remaining things are false. For example, if I perform OR operation, true or true is true, true and false is true, false and false is false, false and true is true. So A or B. And I can also perform negation of A. It will the conjugative. True will be false, 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 true, true. And negation of B, false, true, true, false. So this is about logical operators. And one more thing is that we can also use double ampersand for one element. For example, I want to compare the first element and first element. Both are true, so should be true. The same thing can be done with double ampersand. That is true. So similarly with double bar. So I can write it will A double bar B. It will be done only with one length. So A of one or B of one. Or let us say true. It will be true because true and false, true or false is true. Then we'll move on to see conditions, if and else conditions. So you know that if the condition, what is the syntax for if and else? If condition or test, then if it is true, what we have to do? Condition is true, what has to be done? Then else code for false. So for example, let us take a simple example. So don't bother about that. So let us say x is equal to 4. Some number which is a positive number. I want a program for whether a given number is positive or not. So if x is greater than 0, there is a condition. If it is true, what it has to be done? Print positive. Then we have else print negative. Suppose x is minus 1. And I'll copy the same code. Sorry.
or let us write the same thing in our script. Let us open our file and let us write a program. Check whether a given number is odd or even. So what is the logic here? You will calculate the remainder when we divide by 2. If the remainder is equal to 0, then it is an even number. Otherwise, it is an odd number. So let us take some number y is 4. And what is the condition what is the syntax you will write? If reminder. Reminder symbol in R is double percentage 2. If it is equal to 0, then print print even number, else print odd number. Odd number. Let us run this program. This is oh something we have to do it here. Let us keep bracket. So that is because we have done it in console earlier. We had to write this after this in the console in program. This is even number. For example, if I give 5, then obviously so this is about if and else. So this type of errors occur because it's better we use braces, or others we have to write if and else in the same line. So I have opened brackets and I have closed it here, and else I open bracket and I closed it here. So it is an odd number. So this is because of the brackets we have to fix the error. Then we have one more thing called if else that we can use for vectors. If you are using, if you want to check a condition for all the vectors. So we have, let us say, an vector A is a vector of all the marks, or let us write marks, and C of, let us say you have mid marks here 25, 20, 32, 40, 40, 32, okay, 38 and 10, 20 and 10. And you want to label it as pass or fail based on the marks. So you know that if the marks are greater than or equal to 14, it is passed. So I can write here grade is equal to grade is equal to if else marks greater than. So this is the syntax. If else test yes or no. Marks greater than 14. If that is true, what we want to do. If that is false, what we want to do. So if that is true, grade is pass. And if that is false, grade is fail. So if you print grade, so all are pass and the remaining one is fail. So that means we can also have a column bind to be more clarity. C bind, we can print marks and grade side by side. So this is pass. So what we have learned, we talked about relational operators, we talked about arithmetic logical operators, we talked about conditional statements, if else, and if with vectors, if else. In the next class, we talk about loops.